Greetings, my young math Padawans. This is lesson 3-4, solving quadratic equations using the quadratic formula. So the quadratic formula is the last method for solving quadratic equations that we'll talk about. So one of the big things to remember is that when we have a quadratic equation, the first thing we want to do is we want to set it equal to 0. And then we're going to make a decision about what method we want to use. So if it's factorable, that should be our preferred method because factoring is the easiest method to solve a quadratic equation. But if factoring is difficult, or if we see that there's a perfect square trinomial, we want to use that. Or maybe if that b value is nice and divisible by 2, we might want to consider completing the square and then solving it. If you have just an exponent squared or a quantity squared, then maybe you want to just take the square root of both sides. But if all else fails, or if you don't see what method to use, the quadratic formula is never going to let you down. And it always works. So here's the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, that whole thing over 2a. Using this formula and making sure you write it out every single time is going to be really important until you have it memorized. And yes, I said memorized. Okay, we're going to go through 2 example problems. Then you're going to try 3 on your own, and we'll go over those just like we do in all of the videos here. All right, first example is up here. X squared plus 3x is equal to 5. Before we can use the quadratic formula, it's super important that our quadratic equation is set equal to 0. So I'm going to subtract 5 from both sides and get it set equal to 0. Now, we need to identify what is A, what is B, and what is C in my problem. And that's going to be just like we used when we did our graphing. So in this problem, A is equal to positive 1, B is equal to positive 3, and C is equal to negative 5. We have to make sure we get the sign of the number as well. Now, it's just a matter of filling it in to the quadratic formula. So we'll write X is equal to the opposite of B. B is 3, so the opposite of B is negative 3, plus or minus. That gives us our 2 different answers we're going to end up with for the end of this problem. The square root of B, 3, squared, minus 4 times A, which is 1, times C, which is negative 5. I need to extend my radical. That whole thing goes over 2 times the value for A. So we're going to, at the end, divide by 2 times 1. Now, with the quadratic formula, all we have to do is simplify this. So I have the opposite of 3, plus or minus the square root. 3 squared is 9. 4 times 1 times negative 5 is negative 20. So it will be minus negative 20, which is exactly the same thing as plus 20. Divided by 2 times 1, which is 2. One more step. The plus or minus the square root of 20 plus 9 is 29, divided by 2. Now I'll think about that square root of 29, and I'll say, is there a perfect square and divide into 29? No, there isn't. So this is, in fact, my final answer. If you would type that in your calculator, you'd get some crazy decimal. That crazy decimal is the answer to this problem. Let's try another one. I'll go through this one a little bit faster than the last. So, first thing, always set this equal to 0. So I have 3x squared plus 5x minus 2 is equal to 0. I will take a minute and I'll identify A, which is 3, B, which is positive 5, and C, which is negative 2. I'll fill in the quadratic formula. X is equal to the opposite of B, plus or minus the square root of B squared, minus 4 times A times C, all over 2 times A. And I will simplify now. So I got negative 5 plus or minus the square root. 5 squared is 25. 4 times 3 is 12, times 2 is 24. So I'll do plus 24, all over 6. I'll keep going. Negative 5 plus or minus the square root, let's see, that's 49, excuse me, all over 6. Now, we can keep going. So I have x equals negative 5 plus or minus, let's see, the square root of 49 is 7 divided by 6. Now remember what that plus or minus actually means. it means that I can split the problem to have two different answers. So one of them is going to be negative 5 plus 7 divided by 6. The other is going to be negative 5 minus 7 divided by 6. Let's do some math. Negative 5 plus 7 is 2. So I have 2 sixths. The other one, negative 12 sixths. So my final answer is 1/3 and negative 2. Those are the two answers to this quadratic equation. Sometimes you'll get radicals in your answer. Sometimes you won't. This is the way that will work, though, every single time. So really all we've got to do is use the quadratic formula. So I want you to take a minute right now, pause the video, try these 3 problems out using the quadratic formula. We will go over them momentarily, but first, pause the video and try these on your own. All right, number 1. First thing I'm going to do is I'm going to set this equal to 0. Next, I'll identify a, b, and c. Then I'll fill in the quadratic formula. So the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. 2 times 1 is what I mean. All right, so let's simplify this. So I get 36 minus 16 over 2. I'll go up here. That's x equals 6 plus or minus the square root of 36 minus 16 is 20 divided by 2. In this case, that square root of 20 is actually something that I'm going to be able to simplify down. So I'm going to take that minute, I'm going to simplify that radical just like I'd been doing. So I got 6 plus or minus 2 square roots of 5 over 2. And here's the one thing that's kind of important that we didn't talk about before. I want to make sure I take the time to simplify my fraction if I can. So that means these 2's that I can divide into both the 6 and the 2 that's in front of the square root of 2. I'm going to simplify that fraction and end up with a final answer of 3 plus or minus the square root of 5. Because 2 over 2 simplifies down to 1. Okay, let's try number 2. Here's number 2. Again, first thing I'm going to do is I'm going to set it equal to 0. I will identify a, b, and c. I'll fill in my quadratic formula, the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all over 2a. I'll do the math. I'll get 1 plus the square root of, in this case, 161 over 10. And I'll save you the work. 161 cannot be simplified down at all, so your answer is 1 plus or minus the square root of 161 over 10. Now, if you want to get in the form, you could write that as 1/10 plus or minus the square root of 161 over 10 if you wanted to, but you don't need to write it that way. But either of those answers would be acceptable. One more. 5x squared plus 21x plus 4. No need to set it equal to 0. It's already there. A is equal to 5, B is equal to 21, and C is equal to 4. We'll fill in our quadratic formula, the opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2A. We'll go forth, then we'll simplify this expression, and we'll keep going. And in this case, you had to take the square root of 361, which is actually a number you can take the square root of. It's 19. So I get my two problems, negative 21 plus 19 over 10, and negative 21 minus 19 over 10, and I'll do the math. So negative 21 plus 19 is negative 2. So I will get negative 1/5 as an answer. And negative 21 minus 19 is negative 40. So I will get negative 4 as my other answer. All right, folks, I hope those examples helped. You'll get plenty of practice in class. No worries about that. And I'll see you next time. Have a good day.